All right, the meeting is being recorded now. In case at some moment you cannot certainly listen to me, or maybe if you can get some echo of my voice, let me know. There might be a slight echo. Anyway, good afternoon and welcome to the second session of fundamental and doubt clearing class. Second session is the session of every. There are 3 sessions. I take session every Monday, 6 to 8 p.m. I am Shaptush Shide. I am a PhD in electrical engineering department. I work on electric machine design as a part of my PhD thesis. So in this session, in this week, the topic is method of analysis, that is different method for circuit analysis. Can we get to the recording of previous session? The sessions, there is a sheet that is being shared with all the students, I believe. Okay, I will send you the link once again in the comment box. I have some network issue here, I believe. Voice breaking, can someone please confirm? Can someone please let me know?
So your voice is not that clear.
Sorry, go again.
Your voice is not that clear.
Not very clear. That's a week for this week. I think you have to put up with. Don't have any other option. Wait, I'll change the headphones.
No, can you confirm? Yes, no. We have to start.
No.
Anyway, I cannot hear what you are saying. All right. So this week is about the method of analysis. We will see different ways to solve a circuit, not necessarily always applying directly the theorems, but also easier ways of solving the circuit. But before we go into the problems, as usual, like other classes, I would like to first take doubts from you. So I hope you have already watched the video lectures of this week, and I would like you to ask me questions or doubts of this week as well as of the last week lectures. Go ahead.
So we are finding difficulty in solving the circuits. Can you please make them a bit more clear so that we don't find any problem in solving the assignments which are assigned to us?
Can you please go once again? Finding difficulty in solving what?
So the
Solving what?
circuit problems are finding difficulty in solving, sir.
That's a general doubt. If you are finding it difficult, I would say that look into the methods that I follow, or that's not an universal method, or methods that I follow, or books follow, other TS follow. But I would like to generalize things as much as possible so that we can solve the circuits. I hope this session will help you. Okay. Yeah, specific doubts. This thing of the lecture, this statement of the lecture, I could not understand. This thing I saw in the book, I couldn't understand, or I think it's wrong. Something. How many of you have watched the lecture videos, all the lecture videos of this week?
Yes, sir, I have watched.
You have understood everything.
Actually, I have seen the given concepts, basic concept.
No, no. Uh, videos. Some. Okay, so looks like you guys have no doubt at all. That's quite encouraging. Then I would hope you will be able to solve these questions very easily. Okay. Let us look at this question first. In a voltage divider circuit shown in
So
input voltage.
it is solved with the
Harshal,
help
are
of
you saying something? Harshal, your voice is breaking.
just, now it is coming. Hello. Okay, sir. Continue, sir. Please continue, sir.
Okay. Something is problematic from my side anyway. What to do? All right. I hope you can see. There might be some lag. You can see the question. The voltage divider circuit input voltage is 50 volt, R1 5 kilo ohm, R2 20 kilo ohm, and RL is 12 kilo ohm. So this is 50 volt, 5K, 20K, and 12K. The question is determine the output voltage V0 in volt. Guide me how to approach. My voice is not coming on the other device. I can hear my voice. Is it same for others also? Someone else can
Yes,
confirm.
sir.
Yes, what you can hear or cannot hear?
We can hear you, sir.
I can hear you, sir.
Okay. Okay, go ahead. Rishi, tell me how to approach. We have to find out the output voltage V naught, means the voltage across RL. What should be the approach? Anyone else? Vivek, Javed, Krunali, anyone? What is the
First, we'll
first step?
take 20 and 12 in parallel.
Okay, so how much is 20 and 12 in parallel? How much is the
So it will
equivalent
be
resistance?
32. 20 into 12 divided by 32. 30. 3.33.
3.33.
Just let me check.
Maybe, I don't know. So it should be 1240 by 32. If it is 3.33, then 3.33.
7.5.
Just 3.
7.5, sir.
7.5, right?
Yes, sir. Yes.
Okay. So we have 50 volt and this. So the equivalent resistance is
12.5.
12.5K. Then what is the current that the source is supplying? IS, if I write.
Yeah. Phi is equal to IR 50.
4 ampere, right? Not 4 milliampere.
Yes, sir. 4 milliampere.
So 4 milliamps current is going.
Yes.
So out of this 4 milliamps current, how much drop is sorry, this 4 milliamps current and it is flowing to this 5K. So 20 volt is dropping here, right? Dropping across R1. So voltage drop across R2 is the rest 30 volt. So the question is, so the answer is 30. Is it clear? So this is a potential divider circuit. These things are available in the market. You can buy very common. We call them as pot. In short, we call them pot. So they're basically like this. There is a long resistance and there is a slider or wiper, we say, right? So basically say this is the pot and say there is a knob like this. You can rotate this. When you rotate, this slider moves up and down, and the voltage you get here, say this is V in, this is V out, is depends on the position of the slider. So in this way you will get some output voltage which is always less or equal to the input voltage, and this is the relation between V output and V input is not linear, it's non-linear. Non-linear means if the load changes, say you do not change the wiper position, but if the load changes, you will see the output voltage changes. Okay, And not only that, with the position of the wiper also the voltage does not change linearly if there is a load. Alright, there was a network problem from my side. Did you guys said anything? Say anything? Okay. So if this is clear, we'll go to the next question. For the given circuit in figure 3, the value of R, here it is R, is set in such a fashion that the current through S becomes 0. So R is variable. Under this condition, what is the value of I in amps? How to approach? Is the question clear? The R is resistance R is variable, and it is varying such that there is no current through the resistance S. So under this condition, how much is this current I? So we have to first find out how much is the value of R for which there is no current flowing through S. How to do that?
Well,
How do you know that?
balanced Wheatstone bridge. Under balanced condition, no current to S.
Okay, so what he's saying is Wheatstone bridge. So basically, uh, how to look at it? Let us say there are series of resistances. I show two. There is one, and there is one. One series, and these two series are in parallel, right? Now, if you have R1, R2 here, and R3, R4 here, and if you look at these 2 points, now they are connected across some voltage source V. Now the ratio of R1, R2 that decides how much voltage will be across R1, how much voltage will be across R2. Similarly, the ratio of R3 by R4 will decide the voltage distribution between R3 and R4. Now, if this ratio is equal, then the points A and point B will be at the same potential, because the voltage across drop across R1 and the voltage drop across R3 will be the same. So A and B comes in the same potential. And if you connect something between A and B, there will be no current flowing through it. So in this case, we can see that this resistance 6 ohm is 2 times 3. So R must be 2 times 6. So basically R has to be 12 ohm if you do not want any current to flow through S. Because in that case, the way this 3 ohm and 6 ohm divides the voltage in the ratio, the same ratio 6 ohm and 12 ohm divides the voltage. So the resistance S sees 0 voltage drop across it. Understood? Formula is okay, but this is the way the formula comes. Right? So we now know the value of resistance R. So from here we can find out the net current flowing. So what we have is 9 ohm and 18 ohm in parallel and 4 ohm in series. So the equivalent resistance becomes 9 parallel to 18 plus 4. Can you find out how much this is?
10.
10. If this is 10, then current is 2 ampere. Is this clear for everyone? Okay. Wheatstone. We'll look into this circuit. Current source we have discussed a little bit in the last class. I said I will discuss more later if we get time, but that we'll do later. For now, we'll solve this question. So the circuit is given. In this circuit, determine the power associated with the current source. So power associated means whether the current source is delivering or absorbing power and how much the power is. Okay. So what is given, we will see. The value of the current source is not given. I naught, we do not know how much it is. Rather, we know that 60 volt is there and it is supplying 5 ampere. From here we can find out I naught. So we will assume this to be 0 volt, right? You can assume any point to be 0 volt, but assuming that point to be 0 volt is more convenient. Now 60 volt is here, so this point has a is at a potential of 60 volt. Now 'Okay, we'll start anyway. So if this is 60 volt and 5 ampere current is flowing, can you tell me the voltage here? Five ampere current is flowing across the 8 ohm resistance. What is the voltage drop? How much voltage is being dropped across this resistance? Ohm's law, anyone? 40. So if this is a 40 volt drop, then this point is at a potential of 20 volt. Right? Now, if this point is at a voltage of 20 volt, then 2 ampere current is flowing in this way. Right. Now 5 ampere current was going this way and 2 ampere is going down. So the rest 3 ampere must be going this way. So we have another voltage drop of 12 volt. So this point is at a potential of 8 volt. Now if this is at 8 volt, there must be a 4 ampere current coming down this way. Now 3 ampere was going this way, 4 ampere is coming down, so this must be 1 ampere. So this I naught must be 1 ampere. So we can tell that there is a voltage drop of 2 volt here, but you can see the potential of the voltage drop across the 2 ohm resistance. How I have drawn it's opposite now compared to the others, means it's along the current. Now if this is 8 volt, then this must be 10 volt. Voltage across the current source is 10 volt and the current source is 1 ampere current source. Then definitely the power is 10 watt. Now the options only first one has 10 watt, so definitely the power is delivered. Very poor choice of options anyway. 10 watt we know as of now. We do not know. We do not have the options. We do not know whether it is delivered or absorbed. So how to find out whether the power is being delivered or absorbed by the um, source, current source. Current source can absorb power also. The thing is, in any electrical equipment, I should not draw like this. Any electrical circuit component like this, if you have a voltage or a potential difference of V across the terminals, see I have written lowercase v. It means instantaneous. We discussed in the last class. And if the current in this direction is I, then the instantaneous power is Vi, and if power is positive, that means power is being delivered, and if P is negative, that means power is being absorbed. Okay, so in this case what is happening like this. So the first case, power is being delivered, so definitely 10 watt power is being delivered. Any doubt in this question? Understood? Okay, we look into this question. There are several current sources now in parallel and several resistances. Question is how much current is flowing through the 1/3 ohm resistance, this one, middle one. Tell me what should be the approach, how should I start?
Need to take the 5 meshes and then name them.
Once again. Once again, please.
So we need 5 meshes. Applying the mesh analysis.
We will rearrange the drawing first. Did you suggest that?
Yes, sir. I'm saying that first we will arrange it and then we'll apply the mesh
Yeah.
analysis by naming the mesh.
So this will help us. It doesn't matter whether we rearrange this. I mean, we draw the sources first and which resistance we draw where. Why does it not matter? Because all of them are in parallel. So all of them are getting the same voltage across them. Doesn't matter where I draw. Now, if this is 30 ampere, 10 ampere, and 20 ampere. So 30 is going, 10 comes here. So this must be 20 and 20, 40. So basically 40 ampere is being divided between 1, 7, 1 by third, sorry, 1 by 3 and 1 by 5. These three resistances. So what is the equivalent resistance? 1 by 7 plus 3 plus 5. These are inverse. So 15 ohm is the equivalent resistance. Not necessarily, you need not do like this also. There are current dividing rules. You can use current dividing rules. Anyway, I do not remember the formula. So 15 ohm is the equivalent resistance. Hey, how can it be 15 ohm? Sorry, I'm doing something wrong. Where is it? One by 7, 1 by 3, 1 by 5. Sorry, this will be inverses. Can someone tell me how much it is? 1 by 7 plus 1 by 3 plus 1 by 5. Do this and tell me. A bit fast, okay? I don't have my calculator today. 105 by 71. So this is equivalent resistance. From here you find out voltage, and the final answer is that voltage by 1/3. Can you do and tell me? So this thing equivalently becomes this. This should be the answer. Okay, any doubt in this? Easy question. All right, we'll go to the next question. So in the circuit shown in figure 6, voltage drop across 7 ohm resistance is 14 volt and current through the 4 ohm resistor is 2 ampere. Determine the product of V and R in V omega. Not omega, V ohm, volt ohm. There is no such standard unit like this volt ohms. They have just wanted to ask this. Sorry. Just a second. I hope there will be no more echo.
The previous answer is coming up of 18.
How much? This resistance value have you done by yourself?
So in my way, it's not coming as it's coming in your answer.
Getting something else? Oh, I don't have a calculator today.
I did it in my own way, so it's not coming. Like the answer is not matching. I'll recheck it. I'm sorry, sir, to interrupt.
No need to say sorry. You're trying that, so okay, I will do. I will arrange a calculator. 7 inverse plus 3 inverse plus 5 inverse. Resistance is correct, 105 by 71. So when I multiply it with the voltage, 59 point something. So 59.15 volt is here, right? 15 volt is here. Then voltage by resistance means simply into 3. Hey, what just happened? Why is the current so large?
So for me, it's coming approx 18, like 17.6, which is not given in the option.
Okay. Hmm. 1.7. No, I have done something wrong here itself. The equivalent resistance calculation. Just a second. What is it? It is 1 by R1, right? I wrote it correct at the beginning only. It's 1 by 7 plus 3 plus 5. It is 1 by 15. It's 1 by 15 ohm. Then voltage is 40 by 15 ohm. Sorry, volt. So this is 120 by 15. It is 8 ampere. Clear now? I did a mistake, sorry.
Yes, sir. Now it's
Hmm. Okay. This question is a bit more interesting than the before, than others. So the circuit shown in figure 6, the voltage drops across the 7 ohm resistance 14 volt, that we know, and current through 4 ohm resistance 2 ampere. Determine, basically we have to find out this V and this R. This we have to find out. Okay. How to start? For this question, always start
Sir,
with
can
assuming. Hmm?
sir, you help us in finding the principal node.
Uh, what is a principal node?
Yes, sir.
I don't know what is a
Like how to
principal node.
determine no, how to determine the principal node when we are taking questions of node analysis.
That is your observation. Use some problems, maybe you see the node where you have to write the least number of equations, where you have to do the least amount of work. That is your principal node. There is no such thing. You can start it anywhere. We will we will try to write as less equations as possible to solve these questions. Okay. If it is absolutely necessary, we'll write equation. We'll see. So we'll start with taking this one as a 0 volt, right? Now, if this is 0 volt, tell me what is this voltage? Hmm?
8 volt.
8 volt. Is it clear? Why is it 8 volt, Renessa?
Yes, sir. That is the following the Ohm's law.
Right. Now, if this is 8 volt, it is 8 ohm, then 1 ampere current is flowing here. Right. Now, 2 ampere current is flowing here. 1 ampere current is flowing here. So, 3 ampere current must be coming to this node. Okay. This much we know. 3 ampere current is flowing through resistance. One more thing we have is the voltage drop across the 7 ohm resistance is 14 volt. So this node is at 14 volt. 14 volt. Right? And this node is at how much? Right hand side of R, how much? 8 volt.
8 volt.
Because I have already written 8 here. They are short circuited, these two nodes. They must be at the same potential. Now the resistance R has a voltage drop of 14 minus 8, 6 volt across it, and it is carrying a current of 3 ampere. So 6 volt or a flow of 3 ampere current causes a drop of 6 volt across a resistance. So the resistance must be a 2 ohm resistance. So we have R equals 2 ohm. This is a 2 ohm resistance. Right? And V we have to find out. So this current was 3 ampere current, and there was a 14 volt drop in the 7 ohm
Without the
resistor.
equations also. Just by the Ohm's law, like without the equation.
Yes, this one we could solve. Not every circuit we can solve like this. This one we could. Okay. If we need not apply mesh operation or node analysis or other theorems, we will not. Just because we have tools, we do not have to use them. Okay. So if this is 7 ohm and has a drop of 14 volt, then must be 2 ampere current flowing through it. For today, if you guys have question, you write in the chat. Okay. I think I cannot listen to you properly. From next day, you can ask me directly. Okay, so 2 ampere current is flowing in the 7 ohm. So the total 5 total 5 ampere current is being supplied by the source. Then what is the source voltage? See, this point is at 14 volt, and the 1 ohm is carrying 5 ampere current. So this must be 14 plus 5, 19 volt. Right? There is a voltage drop of 5 volt across the 1 ohm resistance, because we know that it is carrying 5 ampere current. So the left hand side point of the 1 ohm resistor must be 5 volt a higher potential than the right hand side point. So it's at 19 volt. So the V voltage source must be a 19 volt voltage source. So the answer is 19 into 238. Is it clear? We did not use any formula, only Ohm's law. Okay, if this is clear, we will come to this question. A 12 volt battery with an resistance of 1 ohm is connected to a non-linear load. We will go to the question, but what do you mean by a non-linear load? Any idea? Non-linear load means if you do an experiment with the load, say you are giving voltage in steps, say you are increasing the voltage 1 volt, 2 volt, 3 volt, 4 volt, 5 volt, 6 volt, and some current you are getting from the load, and that you are plotting. If you get like this, a straight line passing through origin, this is a linear load. If it is not a straight line, say something like this is a non-linear load. So can you tell me what does, okay, I will,
Which follows the Ohm law, that is a linear node, otherwise it's a non-linear node.
yes, you can say like that. Linear node. Now can you tell me what does the slope of the blue curve define or indicate? The slope of the blue curve is I by V, which is 1 by R basically. What is the reciprocal of resistance?
Conductance.
Conductance. So you can say this is the conductance of the load. Have you studied superposition theorem?
Yes, sir.
Superposition theorem says, say, suppose, simply put, it's like this. Let's say if you give some voltage V1 at some point, say between two terminals of a network, and you are looking at another element R, okay, and it carries a current I1 when the voltage is V1. Now you remove V1 and place V2, you get a current I2. Now if you give V1 plus V2, you will get I1 plus I2. This is superposition theorem, but this will happen only if all the elements in the circuit is linear. Okay? So linear load means where superposition theorem holds, or you can apply superposition theorem only if all the elements are linear. So before applying, you have to make sure all the elements are linear. If you have diodes, transistors like that, in their non-linear zone of operation, you cannot use superposition theorem. Okay. All right. So this load is a non-linear load. A thermistor can be considered a non-linear load. Its resistance changes with temperature. So if the current changes, temperature changes, resistance changes. Okay? Thermistor, whose VI characteristic is given by this. Phi y equals V square plus 2V. So this is how the current through it and the voltage across it are related. The maximum limit on the current drawn by the load is 10 ampere. I don't know why this information is given. We will see while solving the circuit. Determine the current delivered by the battery. How shall I do that? We will apply KVL first, okay? So KVL says 12 equals I into 1 ohm is there, plus V. So what do we have? We have 12 equals I. So okay, instead of I will write V square plus 2V by 5 plus V. So what you have is V square plus 7V minus 60. Oh, I understand now why they have said maximum current is 10 ampere. 60. So what is V? We have to solve this. Solve this. 5 and 12 should be the V plus. Is it? Correct, right? V square minus 5V. Yeah. So there are two options of voltage, 5 volt and 12 volt. Now clearly V cannot be 12 volt, right? Because the source voltage itself is 12 volt. V must be less than, oh no, sorry, V is not 12, V is minus 12. So V can be minus 12 or 5. Now if V is minus 12, then I is 24 ampere. Or V is 5, then I is 7 ampere. So I cannot be more than 10 ampere, they have said. So it must be 7 ampere. Is it clear? Just a simple quadratic equation solution, nothing else. No engineering. Okay, we'll go to this circuit. Is clear, right? We'll move to the next question. All right. In the circuit shown in figure 8, the value of I naught in ampere is. This I naught we have to find out the electricity. Okay, tell me how should I approach?
So
with this question.
you have to like 6 are in parallel and then another is in series, and like for the other also the respective parallel and series will be taken into account. Then we can solve.
Um, have you guys studied about delta star? Delta and star combination of elements.
Yes.
Can you find a delta here? I can find. See, these 6 ohms here, here, and here, they make a delta, isn't it? These 6 ohm resistances make a delta. So I'm just thinking, is it helpful if I replace them with a star connection like this? Because if I do, then what will happen is, say if I call them R1, R2 and R3, they'll be equal. Then what will happen is R2 and 4 ohm will come in series, R3 and 1 ohm will come in series. We can easily solve the circuit. Okay. Now the formula is delta to star conversion formula. So if I write only one, RA equals RAB times RBC by RA plus RB plus R AB BC CA. So if they are connected among this A, B and C, resistance here is AB, resistance here is BC, resistance here is CA. Now do not think that I remembered the formula today morning while I was preparing for this class. I remembered the or memorized the formula. Again tomorrow I will forget. So do not be very anxious about this formula, whether you can remember it or not. The derivation is very interesting. You can go through. But most of the people do not remember. As I told you today morning early, I looked into the formula. So if we go with this, then what I have written as R1, R2 and R3, I will simply write them as R because all the resistances in delta are 6. So all the resistance in star will be the same. So it will be 6 into 6 by 3 times 6. So 2 ohm. So this circuit, I will just draw between these 2 points, A and B. A and B, between these, it becomes like this. Like this. I have 2, 2, 2, 1, 4. So this is equivalent to 2, 6, 3. Okay, let me draw the other parts also. This is 1, the source voltage, 1, source voltage. So 6 and 3 parallel makes AB by A plus B 2 ohm. So another 2 ohm. So 2 to 4, 1, 5. So we have a total of 5 ohm being supplied by a 30 30 volt source. So what we are getting is a 6 ampere current. Now we will backtrack. So 6 ampere current flowing in 6 and 3. So what should be the current through the 6 ohm resistance? It should be 3 by 9, right? 6 times 3 by 9. 2 ohm, 2 ampere. This should be 4 ampere, right? 12 volt, 12 volt, yes. So this is 2 means this is 2. This 4. Clear? So the final answer is 2 ampere. See, in this case, we used a formula. If you guys can suggest me a method without using formula, that will be even better. Can you suggest me a method without using the formula? One thing I would suggest you here for such cases, see, I applied a delta to star conversion here, right? I'll copy this figure. I copy this figure, right? Now you can copy, paste it, wait. Yeah, see, what I did is I applied delta in this, I applied delta to star in this loop of this delta. But see, there were several other possibilities also. There was another delta here. Here there was another delta. Right? That was also possible. But I applied delta to star conversion. One more thing is, see, if you see, there is a star here. There is a star here. Here. I could have easily converted this. I don't know whether this will work or not. I'll see. Say if I convert this thing into delta, how would it look? It would look like this. Would that be helpful? See, this is also, in this way also you can solve the circuit. Why? Because here this, say R1 comes parallel to 6 ohm, R2 comes parallel to 1 ohm, and these two combination are parallel to each other, and sorry, series in each other, and again that series is in parallel to R3. So all these three is possible. I could have done any of them to solve the circuit, but at the end you have been asked to find out the current through 4 ohm. For the other two cases that I shown, that which is currently drawn on the screen, and also the other one that is considering the right hand side delta, that is disturbing I naught, which you have been asked to find out. So try not to disturb that while you are doing the star delta conversion. So what was the advantage? As soon as in this figure we found out that the current through 6 ohm resistance is 2 ampere, we could directly say that I naught is 2 ampere. Right. So this is no rule, but this is a trick. Maybe in some exam you will forget this, you will do this thing the wrong way, then you will find out that, oh, I have made a mistake. Not a mistake, but you have to do many more extra work. In this way, maybe gradually things will come to your mind, how to do things. Okay, any doubt? Any doubt in this question? Let me know. Okay, no doubt. But before going, let me tell you some things that I used to face during my first year. Some things, some thoughts that helped me is that look into the circuit and the short circuits and try to find out the node voltages while solving the circuit. It is very helpful to solve a circuit if you find out the node voltage quickly. Okay. There is one such question at the end, very interesting, we'll see. Okay, this question. In the given circuit shown in figure 9, determine the current delivered by the 8-volt battery in ampere. This current. Tell me how to start the problem. Quickly. I'm audible, right?
Yes, sir.
How to solve, how to start.
So we have to arrange the circuit first.
Okay. See, the thing is, for a current to flow, there must be a closed path, right? So, if the current goes, the current must return. So, if some current goes, say, some I ampere of current goes, can you show me the return path? The current starts from here. Well, I ampere of current. Can you show me the return path? How it will come back? Say that from the positive lead of the battery it starts. How shall it come back to the negative lead? Is there a way? There is no way the current can return. Since there is no way that the current can return, there will be no current in this branch. This source will not supply any current, 0 ampere, because it has no, there is no path for the current to flow. Now we will still solve the circuit. Our answer is done. None of that. We will still solve the circuit. Now remember one thing. Here there is no grounds drawn. Had this question be like this, similar, everything similar, but one ground is drawn here and one ground is drawn here. That means my right hand side loop, this loop, and left hand side loop, this loop, they are now no longer disconnected. Means there is now a connection. Now the current has a path to flow. Now we cannot set 0 ampere. In that case, we have to solve the circuit. But there is no such thing. So we can start with by assuming any point as 0 volt. I will take this point as 0 volt. If this is 0 volt, what is happening is there is 8 ohm resistance, so 2 ampere current flowing in this loop. So 6 volt drop. So this is at 10 volt. This is at 10 volt. Can you tell me what is the potential of this point?
20 volt.
See, whenever I say what is the potential of this point, that point, whatever, I always mean with respect to the 0 volt point, right? So if you say 20 volt, that means that point is 20 volt higher than 0 volt. Now, this point is definitely 20 volt higher than this, but is its potential 20 volt? tell me what is the potential of that point. See, look along this loop. Not path loop, the path, the green path. There is no current through the 2 ohm resistance, this one. There is no current through the 1 ohm resistance, this one. So there is no voltage drop across the nodes. Only voltage is in the battery. The battery is, or the voltage, DC voltage source. It is not supplying any current. That doesn't matter. A constant voltage source always maintains a constant potential difference across its terminals, right? So if that is 10 volt, we will come now step by step. If that is 10 volt, then that point is 10 volt, then this point is also 10 volt, because the 2 ohm is not carrying any current. So the voltage across is, it is 0. This point is 10 plus 8, 18 volt. Again, the 1 ohm is not carrying any current. So this point is at 18 volt. This point is 20 volt below this. So this is at minus 2 volt. Minus 2 volt. And there is a 2 ampere current flowing. 2 ampere current flowing. So 8 ampere drop. So this is at 10 volt. Is it matching? 10 volt. You see 10 volt here, minus 2 volt here. So 12 volt drop, 2 ampere current. 2 ampere current. We already calculate 2 ampere current. Right? So this way you can find out the potentials of the points.
So can you please repeat the volt which you find beside the 6 ohm one? That is the 10.
Sorry, I can't hear you. What did you say once again? Could you please say once again?
The minus volt I understood, but just like opposite to that, besides 6 ohm, how did that come? Like 10 volt, how
This 10 volt, how it came?
yes, sir.
This 18 volt you sorry. This 18 volt you understood?
Yes, that I understood.
This 2 ampere you understood?
Yes, sir.
Now this 2 ampere is flowing through this 4 ohm resistance. So this will cause a drop of 8 volt. So I had 18 here, 8 volt reduces, so I have 10 volt here.
Yes, I got it.
Okay, any more doubt in this question? All right. We'll go to the next question. In the circuit figure 10, the power associated with the dependent current source is how much? We have already seen what is a dependent source, right? There can be current dependent current source, current dependent voltage source, voltage dependent current source, everything. Means 4 possibilities. All right. Again, we will solve this without using any formula very easily. See, I1 is coming. We don't know the value of I1, that's fine. But I1 is coming this way, 3I1 is coming this way. This blue color I do not like. 3I1 is coming this way. So total 4. So 4I1 is going down the 4 ohm resistance. So if you apply KVL in this loop, you will get 36 equals 2I1 plus 16I1, that is 18I1. So you get I1 equals 2 ampere. So what we have is there must be 2 ampere current flowing from this, and this must be 6 ampere current. Now we have been asked to find out the power of the source. How to find out power? Let us find out the node voltages. This is 0 volt. So this is 36 volt. Now 2 into 2, 4 volt drop. So 32 volt. 3I1 is how much? 6 ampere. 6 ampere. So 18 volt in this fashion. So 32 plus 18, 50 volt here. So 50 into 6, 300 watt. Delivered or absorbed?
Deliver.
Sure?
Yes, because we only said if the power is positive, then deliver.
Yes. So the positive current is leaving the positive terminal of voltage. So 300 of watt of power is being delivered by this dependent current source. Any doubt?
So what can be the way to check whether the answer is correct or not in case of complex circuits?
Uh, what is you can check for the voltage and current of the nodes. I mean, voltage of the nodes and current of the branches, and see if all of them are consistent. Between every two node, there is an element. So you find out the currents and voltages and see. You can also do it by energy conservation. Say, for example, if I apply energy conservation here, this thing is supplying 72 watt of power. Let me write the energies in some other color. So this thing is supplying 72 watt of power. This thing is also supplying 300 watt of power. Now let us look at the losses. I will write in blue. So I1 is 2 ampere. So 8 watt of loss is here, and 4I1 is 8. So this much loss is here. This much is here, and 3 6. 54 watt loss is here. So 128, 54, 8. Is it matching? No, what is wrong? Did I calculate the power wrong somewhere?
The voltage
This is-
across 4 ohm resistance is 12 volt, 14 volts. Sorry.
What is 15 volt?
Sir, voltage across 4 ohm resistor is 14 volt. You have written 16.
14 volt. No, I have not written 16. I1 is 2 ampere. So 4 I1 is 8 ampere. 8 ampere is flowing through it. So loss is I squared R. 16 into I squared R. 16 into
Okay,
4.
okay.
Oh,
Okay.
no, here I told you I squared R. I write R squared. 64 I squared into R. Right? Here also it is I squared. So 6 ampere. 6 into 6, 36. 6 I squared into R. 108, right? Let us see. I hope this is correct now. No, something is wrong once again. Where is making a mistake? No, wait. It's correct. 372 watt. 300 watt delivered from here. 72 watt delivered from here. 372 watt. It matched. Okay. All right. This circuit looks mischievous. Determine the current in ampere delivered by the 120 volt battery. This one. This is easy, right? 14 plus 6 is 20. If you write a 20, then this 20, 15, 24, 12, they are in parallel. 20, 15, 24, 12, they are in parallel. Who are in series with 16? Who are in series with 16? And the whole thing, sorry. And the whole thing is parallel to 18. And whatever we get is in series with 7 and 8. Can you find this out? Can you calculate this? So 20 20 is 10. 10, 15, 4. Write this 10, 15, 4, 2. How much is it? 1 by 10 inverse 15 inverse. You guys do okay? Inverse, 2 inverse. Whatever we get, that plus 16. It is. Then this is parallel to 18. This is almost come as 18. So 1 by answer inverse plus 18 inverse. Something has come plus 15. What I am getting is around 23.77. Can you confirm?
Correct.
Okay, so 23.77 ohm is the thing, then current is 5.04 ampere. You want to calculate the node voltages? They are not asked although. Just tell me the trick how to do that. Which node will you take as 0 volt? Okay, I will give you two options. Option A, option B. Which one would you consider as 0 volt node? If you take point B as 0 volt, this node B, it will be easier. Because you see, on the right hand side, there are so many resistances. So if you have the reference there, it will be easy. I will take this as 5 ampere, okay, for quickly doing it. So if this is 5 ampere, then this is 40 volt, this is 160 volt. Again, this is then 160 minus 35, 125 volt, right? 125 volt, and this was 5 ampere. So 125 volt, 18 ohm, you can find out the current, right? I'll just tick mark what is known to us. This is known to us. This current is known to us. So this current is known to us. Current. If this is known to us, then this voltage is also known to us. So we know this voltage, right? This voltage we know. Now, if we know this voltage, then we know this current. We know this current as usual. As I said, in this current. These two currents, if we know, and this current also was known, so we can find out this current. This voltage is already known, so this current we can find out, right? Now from these two current we can find out the current here, and from the voltage here we can find out the current here. Everything can be found out this way. Okay, you don't have to sit and solve everything, the equations. Only every element you keep on applying KVL, 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 it will KVL and KCL. Okay.
So clarify this question kindly once.
Which one? Clarify which one? Tell me once again, clarify which one.
No, it's fine.
I can't understand what you are saying. Is it okay? Or what you write down in chat box. Okay, you write down. I will.
I will
You can.
redo the question once more and then I will tell in the next class.
Okay, okay, sure. This question I was talking about. Very interesting question. Determine the power delivered by the voltage source in what? So this network is there. So there are cross members, not members like this. So in such cases, when you have such complicated things, see what they've done is easy circuit. They have complicated like this. So you have to make this circuit easy once again. What we'll do is easy part, which part is already easy, we'll draw once. This much we'll draw. Now we will go element by element. Let us look at this. Okay, I will name this node as point A, this node as point B. So this one is point A, this one is point B, right? Now tell me, where is the 5 ohm resistance connected? This one. See, it's this end is at point A, the other end is connected through the short circuit to point B, right? So 5 ohm I can draw like this. Okay. Now, if this is point B, this point I can also say B, because they're at the same potential, and if that is A, this one I can call A, they're at same potential. True. Then the 10 ohm resistance is also connected across point A and point B. The 20 ohm resistance is also connected across point A and point B. So this is the equivalent circuit, or this is the circuit drawn in a better way or simple way. Now can you not solve this circuit? Simply 4 resistances in C parallel. Sorry, 36 volt. So how much? 20, 20, 10, 10, 10, 5, 5, 5, 2.5, 2.5 to 4.5. So it is 4.5 volt, 36 volt, supplying 4.5 volt. So power is V squared by R. V squared by 4.5 is 9 by 2. Is it clear? Sir, an appeal. What appeal? Okay, no problem. I will go step by step. Look at the main circuit, okay? That was given in the question. I have named 2 points as A and B. Now, if that point is A, I can also call this point as A. Is that clear? Write in the chat box, yes or no, quickly. We cannot wait for much. If that point is A, the other point that I have drawn in green is also A. Similarly, this is also B, right? Now I will partially draw the circuit. I will only draw the voltage source, 36 volt, 2 ohm, 20 ohm. Hence, this point is A, this point is B, that we have already written. Now we have the 5 ohm resistance. Look at the 5 ohm resistance. It is connected between the points A and B. So 5 ohm, I can draw like this. Any doubt?
No, sir. It's
Similarly, 10 ohm is also across A and B. Similarly, 20 ohm is also across A and B. So basically, these three resistances, 5 ohm, 10 ohm, 20 ohm, they're in parallel.
so if these are shuffled, then also there will be no problem in the calculation.
Who are shorted?
So I mean, if the resistances are shuffled also, then also there will be no problem.
No, in this case, there is no problem because they're in parallel with the 20 ohm resistance. So, yeah, 5, 10, and these two 20s. These four are in parallel. So, if you shuffle them, it doesn't matter. But the 2 ohm you cannot shuffle them with. You can shuffle. No, you cannot. Is it clear?
Yes, sir, absolutely.
Okay, so we have solved all the questions for today. Before we still have 20 minutes, that is because if people did not ask any doubt. We did not ask any doubt. We still have 20 minutes in our hand. If you have any doubt, please ask. No doubt. All right, if there is no doubt, we will call it a day. Next Monday, we will meet once again. I hope before coming to the class, you will complete watching all the lectures. These are doubt clearing classes, not lectures. And ask doubts and questions. And also, you can ask your doubts from this and last week's lectures also. Okay. All right. Thank you. Then have a great day.
Thank you, sir.
I will stop the meeting. Bye.